Water Desalination by Amanda, Madison, and Bretland.
97% of water on Earth is salt water, which leaves only 3% that's drinkable. This makes it hard for some people to get access to clean drinkable water, also making it scarce in some areas. Our interest in this is helping people by making water more available.
I've always been interested in survival skills. After watching Dual Survival and other survival shows, and turning saltwater into freshwater is definitely a survival skill.
Some previous solutions include, in 2015, a group of people from MIT created a water desalination system. The system works by using solar panels that charge batteries to power the electrodialysis machine. This machine works by passing a stream of water between electrodes with opposite charges, pulling both negative and positive ions of salt out of the water. As you can see in this diagram, seawater is flowing through channels and the salt is exiting from a different path than the fresh water. This gave us an idea of using solar energy to power our system because everyone has free access to the sun.
In 2017, a team at Rice University used a method called membrane desalination. It works by hot salt water flowing on one side of the membrane that is semi-permeable. Cold fresh water is flowing on the other side of the membrane. The engineered nanoparticles that turn sunlight into heat are added to the membrane, which allows it to heat up. The salt water then heats up even more, and water vapor that's collected is transferred to the freshwater side of the membrane. In the diagram above, you can see that the salt can't pass through the membrane. This method gave us the idea to collect water vapor and use heat to desalinate water.
In 2017, a team from Manchester created a geomembrane that filters salt out of seawater. The pores of the membrane are small enough that only water can pass through, not salt. In the diagram, it shows the water particles passing through the membrane since they are much smaller than the salt particles.
We chose Wendell Ela as a potential mentor because he is a professor of desalination and water treatment at Murdoch University. We reached out to him through email, but he hasn't responded to us yet. The goal of this project is to produce a desalination system that efficiently removes salt from salt water at a low cost. We plan to use the sun in order to make water vapor. We also plan to design and make a system so that anyone can make it themselves. We will measure the success by measuring how much salt is in the desalinated water. We will use a refractometer. A refractometer measures the percent of salt in the water. This is a picture of it, and we will know that we have met our goal when there is no salt in the water. Our prototype will consist of 2 buckets, a large one and a small one. They will be covered in saran wrap and then put in the sun so that it collects water vapor in the smaller bucket. We will know the process is done when all the water in the large bucket has transferred to the smaller buckets. We'll know our project is a success when the water is completely free of salt and you can drink it. After making and testing the prototype, we'll modify it as needed and make it visually pleasing. Weather might affect how our design works because we are using solar energy, which is outside. We can't control the weather, but we can plan our desalinating days accordingly. We should handle hot water carefully and let it cool down before further testing. Nothing we do for this project will have harm for the environment. Time could be a limitation because the desalination could take a while, and if the weather is bad, it could put us behind the schedule. Our plan of development is still to be determined, but as of right now, this is what we have. Put water in a bucket, mix some salt in it, and then we will put an empty bucket in that bucket of water, put saran wrap over both of the buckets, and put them under the sun for at least a day. After that, we will measure the amount of salt in the water with the refractometer. We will collect our data using a table consisting of 2 trials of a small and large scale system. The salt before and after the desalination process will be measured, and the effectiveness of the desalination process will also be measured. The materials that will be used are tap water, and we will get that from our house, and we will be using table salt from the grocery store, and we will have a 5-gallon bucket and a 12-ounce bucket, which will be at our house, and a refractometer, which will be provided by the school, and saran wrap, also from the grocery store.